Good morning, children. Today we will do frequency modulation. Now, what is frequency modulation? In frequency modulation, it is also called FM. The frequency of the modulated wave changes with time. Changes with time. Like without any signals, whatever the frequency of the modulated wave, that is equal to the frequency of a carrier wave. Okay, the carrier wave and the modulated wave have the same frequency without any signal, but when it get frequency modulated, when the input signal is positive. For example, I am giving you, suppose you have a carrier wave. High frequency wave is called as carrier. It is a high frequency wave, so it is called as carrier wave. In the previous we discussed carrier wave is a high frequency. Now suppose this is your input signal. This is your input signal which needs to be modulated. Now here signal is positive and here signal is negative. He said that when the input signal is positive, the frequency of modulated wave, so after when they will superimpose, they will give modulated wave. Kehta when it is positive, the frequency of this wave, means whatever modulated wave will come, that will increase. See here it is positive. So when they will superimpose, whatever wave will come after modulation means when the low frequency signal superimpose on a high frequency carrier wave, that is called as modulation, and the new wave formed is called as modulated wave. When signal is positive, here the frequency of, when the input signal is positive, the frequency of this modulated wave is increased. So here frequency will be very high. Okay, same as that of this, same रहेगी, मतलब the not same, like they will come close, that's why it is increasing. Where signal is negative, here signal is negative, where input signal is negative, the modulated wave, what will happen? The frequency of modulated wave becomes less. See, frequency changes. So when the input signal is positive, the frequency of modulated wave get increased, so that the larger than the frequency of carrier wave. इसकी frequency से यहाँ पर, if here the whatever frequency it is, it will increase over here. Suppose here frequency is 5, it will become 7 over here. The larger the signal, the greater is the increase in the frequency. When the signal is positive, when the signal is negative, here when it is negative, the frequency of modulated wave is less than the frequency of carrier wave. Whatever frequency is here it will be less now. Okay, this shows the frequency modulation. In frequency modulation, again it is positive, so it will increase. Again where it is negative, it will decrease. So this is called as FM modulated wave, that is frequency modulated wave. In frequency modulation, the modulated wave has a constant amplitude, amplitude will not change. It is the frequency of the modulated wave that changes as the signal changes. In this, the frequency changes, increasing, decreasing, increasing, decreasing. So frequency of the signal get changes. Now the frequency deviation of the carrier wave may be given a value. Okay, whatever it has come, so some value may be given as per the whatever value of this signal or this signal carrier wave is given to you. Now next is, so somewhere frequency is increasing and somewhere it is decreasing. This causes the side bands or bandwidth. So next topic is side bands or bandwidth. What are side bands and bandwidth? See, A carrier wave contains only one frequency. It has only one frequency. Okay, let it be FC. A carrier wave contains only one frequency. Let it be FC. When the carrier wave is modulated in amplitude by a signal frequency, suppose FM, like suppose we did in the amplitude modulation, let FC is a carrier wave frequency, let F is the signal, input signal frequency. When the carrier wave is modulated in amplitude, amplitude की बात कर रहे हैं, now we are talking about amplitude, is modulated in amplitude, then in amplitude by signal frequency, let signal frequency is FM. Then the carrier wave is found to contain two more frequencies. After modulation, then it contains, what contains the carrier wave? Then it contains means which wave? The carrier wave contains two more frequencies, where one is increasing, another is decreasing. Okay, two more frequencies known as sidebands frequency. What are they called as? They are known as sideband frequencies. What is that? So suppose here it is FC. So somewhere it is, one side it is FC minus FM and another side it is FC plus FM. So in the modulated wave, you will get, suppose you have a frequency 100, this has a frequency 10, so you will get here 90 and here 110. Okay, if FC is 100 and FM is 10, then it will be 10, 100, it will be FC minus FM means 90 and here another band is 110. Okay, so when the music or speech is transmitted, when you transmit, we are talking about the communication, so when the music or speech is transmitted, the carrier wave is modulated by the range of frequency. Okay, this is called as range of the frequencies. Each frequency FM represent a signal gives rise to the extra pair. So for each FM, each frequency, for each signal, there will give rise to the two more frequencies, two more frequency pair like this, and that means you can say one more extra pair of frequency in the modulated wave. The result is the band of frequency, and this is called as upper and this is called as upper bands and lower side bands stretching above and below the carrier frequency. ठीक है, this is called as lower side band and this is called as upper side band, stretching the above and below the value of the highest modulated frequency, that is FC. Now this, suppose you have this, I'm giving you the example of, you have a carrier wave, it has a frequency 1 Hertz. Okay, now suppose the frequency spectrum of a carrier wave has a frequency 1 megahertz, take it as 1 megahertz. It is a high frequency wave, na? Carrier wave is a high frequency wave, modulated with the frequency between, it is being modulated between the frequency between 0 and, what is the frequency of FM in signal? 15 kilohertz. 15 kilohertz means you have to convert into megahertz. It will be 15 divided by 1000, so it will be 0.015 megahertz. 0.05 megahertz. So the highest frequency present in the spectrum will be, how much it will be? So it will be FC minus FM and FC plus FM, lower side band and upper side band frequency. So it will be FC minus FM will be, that means 15 1 minus, it will be 1 minus 0.015. So it will become 1 minus 0.015. So it will become 0.985 megahertz. And sorry minus, and plus it will be 1 plus 0.015, it will be 1.015 megahertz. Okay, so it will be your FC, and here it will be FC minus FM, and here FC plus FM. Its value will be 1.015 megahertz, and here it will be 0.0985 megahertz. The actual shape of the side bands will be vary at an instant and the signal changes. Okay, so the maximum and the minimum value are important. Maximum and minimum. So basically here it is changing. So what is frequencies are varying? This instead of this, now these two frequencies are important. Side band frequencies are important. The maximum and minimum values are important at their as these must not overlap the sidebands from the other two radio stations, because every station has its own carrier frequency but there is no chance that frequency of that lower sideband and upper sideband of any radio station get matched with the another radio station. So there is a less chances of interference over here. The value of FM needed depends upon the quality required. Okay, high quality music only needs a frequency, like if you are talking about the music, it needs the frequency FM equals to 15 kilohertz. Even though, like for the music you need 15 kilohertz. Now even though that the human ear can hear frequency up to 20 kilohertz, speech only needs, for speech we need a FM up to 3.4 kilohertz, because for people to understand one another. So you can see the modulated carrier wave occupies a region of the spectrum. So here is modulated wave. This is your modulated wave. This is the spectrum of the modulated wave. Its frequencies vary from 0.0985 to 1.015. This is varying. So the bandwidth of the signal is the range of the frequency. How you will find out the bandwidth? This is the bandwidth. Now how you will find out? This minus this means FC plus FM. So now the bandwidth will be, suppose you have FC and here FC plus FM and here FC minus FM. So bandwidth will be now this FC plus FM minus FC minus FM. When you will solve this, FC plus FM minus FC plus FM, so it will be now 2FM. So in our case, what we took, it was 1 megahertz. So lower sideband frequency it was 0.985 and upper sideband frequency 1.015. So what is the bandwidth? Bandwidth will be now 1.015 minus 0.0985, that is 0.030 megahertz. Okay, so now the bandwidth will be twice of this, twice of FM. This, what was FM? FM was taken was how much? 15 kilohertz means 0.05 is it 0.05 megahertz. So this was about the how you get the frequency modulated wave. Okay, now this was all about the frequency modulated wave. Now how can you compare the AM and FM? That we will do in the next lecture. Thank you.